Hi friends, in today's video let us learn how to find the eigenvalues and eigenvectors of a 3 by 3 matrix. So the question given is find the eigenvalues and eigenvectors of the matrix A equal to 2, 2, 0, 2, 1, 1, minus 7, 2, minus 3. So the given data is matrix A of 3 by 3 order. You have to find the eigenvalues and eigenvectors for the given 3 by 3 matrix, right? So the solution is in 3 steps. Step 1, find the characteristic equation. Step 2, find the eigenvalues lambda. Step 3, find the eigenvectors. Okay. So step 1, find the characteristic equation. So the characteristic equation for matrix A is given as determinant of A minus lambda I equal to 0. On expanding the determinant of third order, the characteristic equation takes the form lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So this equation is the shortcut method. So if you use this method, it will take some time. So using this shortcut method, what happens is this is the expanded form of the third order determinant, right? So if you use this, you will save time and also the solution will always be correct, right? Okay. So this equation generally I will recommend for all of you to use whenever you are having a problem in third order. Okay. So this is a easy method. So I'll take this equation as equation number 1, where S1 is trace of matrix A, S2 is sum of minors of main diagonal elements, S3 is equal to determinant of matrix A. So let us find now the values of S1, S2 and S3. S1 is equal to trace of matrix A. It is equal to sum of all main diagonal elements. We know the matrix A here. For this matrix, the elements 2, 1 and minus 3 are the main diagonal elements. Okay. If I add the value of all these 3 elements, I will get the trace of matrix A. Therefore, S1 is equal to 2 plus 1 plus negative 3. It is equal to 2 plus 1 minus 3. It is equal to 0. Therefore, the value of S1 is equal to 0. Now, S2 is equal to sum of minors of main diagonal elements. Because I have 3 elements here, the main diagonal elements. Therefore, for each element, if I get a minor, I will be getting 3 minors here. So if I add the values of all the 3 minors, I will get the S2. So first let me find the minor of each element. Okay. So S2 is equal to, I have the matrix A, the first element is 2. For this element 2, I must find the minor. So the procedure is eliminate the corresponding column and the corresponding row. The determinant of the remaining 4 elements, that is 1, 2 and 1 and minus 3 is the minor of the first element. Okay. Plus, again the matrix here, the second element taken is 1. For this element, find its minor. Again the procedure is eliminate the corresponding column and the corresponding row. Determinant of the remaining 4 elements, that is 2 minus 7, 0 and minus 3 is the minor of the second element. Okay. Plus, again take the matrix, the third element taken is minus 3. For this element, if I want to find the minor, the procedure is eliminate the corresponding row and the corresponding column. Okay. Determinant of the remaining 4 elements, that is 2, 2, 2 and 1 is the minor of the third element. So I have got the minors of all the 3 elements. Okay. Now we know that how to find the determinant of second order. Suppose I have 4 elements here. I have to go for the cross multiplication, that is AD minus BC. Using this rule, I will solve all the 3 determinants here. So therefore, it is equal to, let me show one by one, 1 into minus 3, 1 into minus 3 minus 2 into 1, 2 into 1 plus the second one now 2 into minus 3, 2 into minus 3 minus negative 7 into 0, negative 7 into 0 plus the third one now, it is 2 into 1 minus 2 into 2. So I have solved it now. Let me simplify it. It is equal to minus 3 minus 2 plus negative 6 plus 0 plus 2 minus 4. Okay, let me again simplify this. It is minus 5 minus 6 minus 2. It is equal to minus 13. If you are compatible by using the calculators, you can directly enter the values here, okay, and get the value as answer as minus 13. Okay. Now S3 is equal to determinant of matrix A. Okay. So again, we know the determinant 2, 2, 0, 2, 1, 1, minus 7, 2 and minus 3. We have to find the value of this, right? Determinant of matrix A. So again here, to find the determinant, here in this case, you can take any column or any row. Generally, we take the first row. Okay. Now in this first row, the first element is element 2. So write the value of 2 here into its minor. Got it? The element 2 into its minor. To find the minor of this element 2, again the procedure is eliminate the corresponding row, corresponding column, the determinant of the remaining 4 elements. Okay, that is its minor. So determinant of 1, 2, 1 and minus 3. Okay, again the next one. Again I am taking the first row, second element. Now you have to be very careful here. So the signs are there. It is plus, minus, plus. Okay. So for the second element, you should write minus 2. So I am writing it here minus 2. Now find the minor of this element 2. Okay. So again the procedure is eliminate the corresponding row, corresponding column. The determinant of the remaining 4 elements is its minor. So determinant of 2 and minus 7, 1 and minus 3. So the last one is, again I know the matrix A. I am taking the third element 0 here. Now plus 0, right? Now find its minor. Eliminate the corresponding row, corresponding column. Determinant of the remaining 4 elements is its minor, right? So determinant of 2 and minus 7, 1 and 2. So now I have got these values. I have to solve it now. Again the same 2 by 2 order determinant, how to find its value. It is cross multiplication AD minus BC. So see here, it is 2 into 1 into minus 3 minus of 2 into 1 minus 2 into cross multiplication 2 into minus 3 minus negative 7 into 1 plus O, that is 0, into 2 into 2 minus negative 7 into 1. So you can directly feed this in the calculator and find the answer, or go step by step. So it is 2 into minus 3 minus 2 into negative 6 minus negative 7 plus 0 into 4 minus negative 7. Again simplifying it, you get 2 into minus 3 minus 2 into negative 6 plus 7 plus 0 into 4 plus 7. So it is 2 into negative 5 minus 2 into 1 plus 0 into 11. Again simplifying it, it is equal to minus 10 minus 2, it is equal to minus 12. So the value of S3, that is the value of the determinant of matrix A, is equal to minus 12. So we know now S1 value is equal to 0, S2 is equal to minus 13 and S3 is equal to minus 12. Characteristics equation for 3 by 3 matrix is given as lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. That is equation number 1. Substitute the values of S1, S2 and S3 in equation 1. So let us now substitute. Lambda cube minus S1 is equal to 0. Therefore 0 into lambda square plus S2 is equal to minus 13, right? So it is negative 13 into lambda minus S3 is equal to minus 12. Therefore it is minus into negative 12 equal to 0. Let us now simplify this. It is lambda cube minus 0 into lambda square minus 13 lambda plus 12 equal to 0. So the characteristics equation is lambda cube minus 0 into lambda square minus 13 lambda plus 12 equal to 0. So this is our equation number 2. So we have finished the step number 1. We have found the characteristics equation for the given matrix, right? Here you can see I have taken all the higher orders, lambda cube, lambda square, lambda, and this is a constant. So maybe the coefficient of lambda square is 0. I have kept this lambda square because sometimes we may forget this value and we may tend to do some error. So generally I keep it in my solution, but if you know how to solve it, you can remove this term. That's your this one, okay? But I will recommend to keep this term because somewhere you will not tend to forget it, right? So now I have found the characteristics equation of the given 3 by 3 matrix. Step 1 is completed. Now step 2, find the eigenvalues lambda. Eigenvalues lambda are the roots of the characteristics equation, okay? So the given equation is lambda cube minus 0 lambda square minus 13 lambda plus 12 equal to 0. That is equation number 2. Okay. So we have to find which values of lambda will give the solution 0. Right. We have to find 3 values here because it is a cubical equation. We have to find 3 values of lambda which will give the solution 0. So we have to go for some easy or known methods. So the first one is factoring the cubic equation, that is equation number 2, using rational root theorem. So out of all the 3 roots, 3 values which will make it 0, I will find the first value using the rational root theorem, right? So using rational roots theorem, all possible rational roots are, so for this equation we must know first of all what are all the possible solutions, which values will give the equation solution equal to 0, right? So this is the equation. Now take the last constant value as p and the first one highest order as q. Now it is equal to factors of the value of p, that is 12, divided by factors of q, that is the value here is 1. So here you can see the value of p is 12 and here the value of q is, the coefficient value is 1. Let us find what are all the factors of 12 and factors of 1. It is equal to plus or minus 1 into 12, so 1 is a factor, 2 into 6, 2 is a factor, 3 into 4 is equal to 12, 3 is a factor, 4 into 3 equal to 12, so 4 is a factor, 6 into 2 is 12, so 6 is a factor, 12 into 1 is equal to 12, so 12 is a factor. So plus or minus 1, 2, 3, 4, 6 and 12 are factors of 12. Now factors of 1 are plus or minus 1. So we know that factors of 12 is plus or minus 1, 2, 3, 4, 6, 12. Factors of 1 is plus or minus 1. So it is equal to plus or minus 1, 2, 3, 4, 6 and 12. So amongst this, any one or maybe even 2 or 3 can be the factors, the solution which will give the solution as 0. That is the roots of this given equation. Let us now take one by one and find which is the right root for this equation. Okay. So now I am just writing it in my solution here. All the possible rational roots are lambda equal to plus or minus 1, 2, 3, 4, 6 and 12. So now let us check for each factor and find the 0 of the cubic polynomial. So let us take now f of lambda is equal to lambda cube minus 0 lambda square minus 13 lambda plus 12. Now out of all these possible values I am taking the first one plus 1. So I am putting f of 1 is equal to 1 cube 0 into 1 square minus 13 into 1 plus 12. Substitute the values of lambda by 1. Now solving this or simplifying it, 1 cube is equal to 1, minus 0 into 1 square is 0, minus into 13 into 1 is minus 13 plus 12. So if I add 1 minus 0 minus 13 plus 12 it equal to 0. Therefore, luckily for me, the check which I did now, the first value 1 is the root of the cubic polynomial. Okay. So I have found the first root. So lambda is equal to 1. Therefore, lambda is equal to 1 is the root of equation 2. Got it? So I have found the first root. That is, I have, out of all the 3 eigenvalues, I have found the first eigenvalue, lambda is equal to 1. Now I have to find the remaining 2 eigenvalues, the 2 remaining roots of the equation. So lambda equal to 1 is a 0 of the given polynomial, which implies lambda minus 1 is a factor of the given cubic polynomial. Let me show it here. So suppose lambda is equal to 1, right? If I bring to the other side, that is the left side, lambda minus 1 equal to 0. Therefore, lambda equal to 1 is the root. Lambda minus 1 is the factor. You got it? Okay. So here whenever I say about all those things, you must clearly understand. So I am saying here lambda equal to 1 is the root. Lambda minus 1 is a factor. Okay. Now dividing the equation lambda cube minus 0 lambda square minus 13 lambda plus 12 by the factor, by synthetic division we have. Now we want to reduce this cubical equation into quadratic equation, right? So we want to divide the equation here by one of its roots. Okay. So we will go for the synthetic division, draw the vertical line and a horizontal line. Here in the first row, write the coefficient of the characteristics equation. Now here the coefficient of lambda cube is 1. So write here 1. The coefficient of lambda square is 0. Write 0. The coefficient of lambda is minus 13. And the last one is constant. So here in the first row, I have written the coefficients of the characteristic equation, right? Now I will divide this by the value 1. That is the first value of the eigenvalue here. Okay. So I'll put 1 here. Now synthetic division, what we must do is initially first write value 0 here. Now below 1 if I write 0 and add 1 and 0, it is equal to 1. Okay. Next step, multiply this 1 into 1. It is equal to 1. Write it here below 0, the next coefficient. Okay. So 1 into 1 is 1. Add now 0 and 1. It is equal to 1. Again multiply this 1 and 1 here. 1 into 1 is 1. Right below minus 13. So minus 13 plus 1. If I sum this minus 13 and 1, it is equal to minus 12. Again multiply 1 and minus 12. It is equal to minus 12 right below 12 here. So if you sum it, 12 minus 12 is equal to 0. So it's very clear that the last value is 0. Therefore, these 3 values are the coefficients of the quadratic equation. Got it now? So let me write it here. We can write this as, this 1 we can write as factor lambda minus 1 into, and these 3 are the coefficients of the quadratic equation. Therefore, this 1 lambda square, 1 lambda minus 12 is the constant. So now I have reduced this cubical equation into 2 factors, lambda minus 1 which is 1 root and a quadratic equation. Now I will take this equation as equation number 3. Now we can factorize the quadratic equation by splitting the term. So this is the equation now, lambda square plus lambda minus 12 equal to 0. Now for this equation I have to find the 2 values which will give the solution 0, by which I can also find my eigenvalues, right? So what I am going to do is, the method approached is splitting the term. Let me take this equation as equation number 4. Factoring quadratic equation by splitting the term, lambda square plus lambda minus 12 equal to 0, that is equation number 4. If you multiply the 2 split terms, it must be equal to minus 12. That is, the value here, the constant value is minus 12. If you multiply the 2 terms, you must get minus 12. Let me see here what are all the possible terms. If I multiply, I get minus 12 value. So 1 into minus 12 is minus 12. Minus 1 into 12 is minus 12. 2 into minus 6 is minus 12. Minus 2 into 6 is minus 12. 3 into minus 4 is minus 12. Minus 3 into 4 is minus 12. So these are all the possible two terms. If I multiply, I get the value minus 12. Now I must find what is the right one. Okay. Here we know that if I add the two terms, it must be equal to plus 1. This plus 1 value is taken from here. The coefficient of the second term is plus 1. So if I add these two terms whose value is equal to minus 12, if I add these two must be equal to plus 1. Therefore, let me check it here. 1 plus negative 12 is minus 11. Minus 1 plus 12 is plus 11. 2 plus negative 6 is minus 4. Minus 2 plus 6 is 4. 3 plus negative 4 is minus 1. Minus 3 plus 4 is 1. So you can see here I got the value 1, and these two split terms minus 3 and 4 are the split terms, right one. Okay. So I have split this 1 as minus 3 plus 4. So now you can substitute this value here in this equation. I am just writing it here as lambda square, and plus lambda, instead of writing plus 1 lambda, I am writing it as minus 3 lambda plus 4 lambda. So I have split here 1 as minus 3 and plus 4. You got the point? So the full equation is lambda square minus 3 lambda plus 4 lambda minus 12 equal to 0. Let me show it here. So here I have lambda plus 1 lambda. I am making it as, splitting it as minus 3 lambda and plus 4 lambda. Minus 3 lambda plus 4 lambda is equal to lambda. So I have used the splitting the term approach here. Okay. Now let us go for the factorization. Lambda into lambda minus 3 plus 4 is taken commonly outside into lambda minus 3. The common factor is lambda minus 3. Therefore, lambda minus 3 into lambda plus 4 is equal to 0. Let me find the solution here. I will take it separately. Lambda minus 3 equal to 0 and lambda plus 4 equal to 0. Bring 3 other side. You get lambda equal to 3 and lambda is equal to minus 4. So I have got the eigenvalues, lambda equal to 3 and lambda equal to minus 4. So on factoring the characteristics equation, we can express it as lambda cube minus 0 lambda square minus 13 lambda plus 12 is equal to lambda minus 1 into lambda minus 3 into lambda plus 4. Thus, the eigenvalues of A are lambda is equal to 1, 3, minus 4. That is, lambda 1 is equal to 1, lambda 2 is equal to 3, lambda 3 is equal to minus 4. These are all the eigenvalues whose values will give the solution 0, right? So these three are the eigenvalues. Step 2 is completed. Step 3, find the eigenvectors. We all know if X is an eigenvector of matrix A corresponding to eigenvalue lambda, then X will satisfy the equation A minus lambda I into X equal to 0 if X1, X2, X3 be the components of X. So here this is A, matrix A, minus lambda into I into X equal to 0. Here this matrix is the identity matrix whose diagonal elements are 1 and the remaining elements are 0. And also you can see that this is a 3 by 3 order matrix because the given matrix A is 3 by 3 order. Therefore, take I of 3 by 3 order, right? Now simplify this, keep A first just like that. Just multiply lambda into I. You can see here I have kept the matrix A just like that. Minus lambda into I gives lambda into 1 is lambda, lambda into 1 is lambda, lambda into 1 is lambda. So wherever I had 1 here, I have just multiplied with lambda and I have got lambda here. Okay, that's it. Now let me subtract matrix A and lambda I. You can see here, if I take the first row here and the first row here, 2 minus lambda is 2 minus lambda. 2 minus 0 is 2. 0 minus 0 is 0. Coming to the second row, 2 minus 0 is 2. 1 minus lambda is 1 minus lambda. 1 minus 0 is 1. Minus 7 minus 0 is minus 7. 2 minus 0 is 2. Now coming to the third element of the third row, minus 3 minus lambda is minus 3 minus lambda. So here I have first multiplied lambda into I, okay. Then I have subtracted matrix A with lambda I. So I get this equation. This equation is equation number 5. I will keep this as a general equation. Using this equation, I will try to find the eigenvectors for the corresponding eigenvalue. Now case 1, putting lambda 1 equal to 1, that is eigenvalue is equal to 1, and this is my equation number 5, the general equation. Let me substitute the value of 1 here. So let me show it here. Wherever I have lambda, substitute that by value 1. So I have 3 lambdas here. First in first row, first element. Second in second row, second element. Third in third row, third element. Okay. Now in all these places, substitute that by 1. So you can see here, this is 2 minus 1, right? This is 1 minus 1, and this is my minus 1, minus 3 minus 1. So substituting the value of lambda here in equation number 5, I get this new values, right? Okay. Now simplify this. 2 minus 1, it is equal to 1. The second row, second element, 1 minus 1 is 0. The third row, third element is minus 3 minus 1 is minus 4. So here you can see it is 1, 0 and minus 4. So this matrix into X matrix is equal to 0. Now to get the solution, we have to multiply these two matrices. Okay. So multiplying the matrices we have, generally we will get 3 equations. How to get that? Let me explain you. So the first equation, let me again show it here. Take the first row. Okay. Multiply the first element with the first element here. 1 into x1 is x1. Then again second element with second element here. 2 into x2 is 2x2. Third element and the third element here. 0 into x3 is 0x3. It is equal to 0, equation number 6. So multiplying the first row and the column, okay, you get the first equation. Okay. Now coming to the second equation, take the second row. Okay. Multiply the first element with the first element here. Okay. 2 into x1 is 2x1. Then second element, 0 into x2, you get 0 into x2 here. Then the third element, 1 into x3, you get x3 here, equal to 0, equation number 7. Okay. Now the third equation, take the third row here. Okay. Now multiply the first element with the first element here, minus 7x1. Okay. Then 2 into x2, you get it here, 2 into x2, you can get it here. Okay. Then minus 4 into x3, minus 4 into x3, you get it here, minus 4 into x3. So this is how you get the third equation, equal to 0, equation number 8. So multiplying the two equations, okay, multiplying the two matrices, I get 3 equations here. Using these 3 equations, I will try to find the variables here. What is the value of x1, x2 and x3. Now these are the 3 equations here. All the 3 equations are different. So we can solve using any 2 equations. Therefore I will be taking here equation number 6 and equation number 7. You can solve using any 2 here. I am just taking 6 and 7. It is your wish. Okay. Now here we can solve this equation using cross multiplication rule. Now how to do it very simply is, first write x1, x2 and x3 here and draw some trees here. Okay. Now you can see here I am starting with x1. So leave this x1. Okay. Below x1 now, first write 2 and 0. Just go to the right side, write 2 and 0 here. Got it? Write 2 and 0 here. Next, below x, in x3, the coefficients are 0 and 1, right? 0 and 1. So below x1, I have written the values on the right side. That is, I just left the x1 coefficients. I am starting from x2. So I have written 2, 0 here, 2, 0 here, and 0, 1 here. Okay. I have to fill these two also. No. So what I do is, once I finish this, I go back to the initial point. Okay. So what I do here is, I now start from here. So 1 and 2, the coefficients of x1 is 1 and 2. So write here 1 and 2. Then again go move right side. Okay, it is 2 and 0. This is 2 and this is 0. Write 2 and 0 here. So this is how I am just writing the values, 2 0, 2 0, 0 1, 1 2 and 2 0. I am just going in cycle. So I have started from x1. I have written 2 and 0, then 0 and 1. Then again I went back 1 and 2, then again 2 and 0. So this is how I got this value, right? Got it? Now what is the importance of this is, let me show it here. So using cross multiplication rule, write the ratios x1 by, x2 by, then x3 by. Okay. So below this, write the determinants. Determinant, just simply draw the two lines here. So these are the four elements. Write it here. It is 2 0 and 0 1, right? It's very easy, right? Doing this format, and this procedure will help you to write it correctly sometimes. Okay. So next one, below x2, again draw determinant. Now below this one, you just draw the two lines. So it is 0 1 and 1 2. Got it? Now the third one, below x3, draw the determinant, and simply below x3 here, draw determinant here, draw the two lines here. It is 1 2 and 2 0. So I have found the three determinants here very easily. Okay, because I have chosen this approach. This is very easy one. You can use it in the class and exam also, because you can make it faster, and even when you write the elements here, it will be right. Okay. Now I have got the three determinants here. Let me solve it here. The three ratios x1 by, x2 by, x3 by. I know that for a 2 by 2 order determinant, the solution is cross multiplication. So here you can see it is AD minus BC. Similarly, do it here also. It is 2 minus 0. 2 into 1 is 2. Minus 0 into 0 is 0. 2 minus 0. The next one is 0 minus 1. 0 into 2 is 0. Minus 1 into 1 is 1. The next one is 0 minus 4. 1 into 0 is 0. Minus 2 into 2 is minus 4. So let me simplify it. So it is x1 by 2, x2 by minus 1, x3 by minus 4. That is 2 minus 0 is 2, 0 minus 1 is minus 1, 0 minus 4 is minus 4. So now here the eigenvector x1 is equal to 2, minus 1 and minus 4. Okay. So the eigenvector for lambda 1 equal to 1 is x1 equal to 2 minus 1 minus 4. I have found the eigenvector for the corresponding eigenvalue equal to 1. Similarly, I will now go on to find the eigenvector for the remaining two eigenvalue in the same method. Case 2, putting lambda equal to 3. So this equation number 5 is the general equation. In this equation, substitute the value of lambda equal to 3 and find the corresponding eigenvector, right? So here you can see here, I have put the value of lambda equal to 3. So let me show it here. So in the first element, first row, it is 2 minus lambda. I have put here 2 minus 3. That is the value of lambda equal to 3. The second element of the second row, it is 1 minus lambda. I have put that as 1 minus 3. Okay. Coming to the third element of the third row, it is minus 3 minus lambda. I have put as minus 3 minus 3. Got it? So thereby, I have put the value of lambda in this equation number 5. Okay. Now let us simplify. This is equal to 2 minus 3. The first element of the first row. 2 minus 3 is equal to minus 1. The second element of the second row 1 minus 3 is minus 2. The third element of the third row is minus 3 is minus 6. Okay. So I have simplified it. Now this matrix into x equal to 0. Using this particular equation, I have to now proceed to find what is the value of x1, x2 and x3. The first step what I do is multiply the matrices. So after multiplying the matrices, what do we have? We will be having 3 equations. Let us see how to get the 3 equations. So the first equation how I get is, take the first row and this column. Okay. You can see, multiply the first element of the first row with this element here, first element here. It is minus x1. Minus 1 into x1 is minus x1. 2 into x2 is 2x2. Okay. Then you have 0 into x3 equal to 0x3. So this is equal to 0, equation number 9. Okay. So using the first row, I have got the first equation. Got it? Okay. Now coming to the next equation, go to the second row. Okay. Now the first element of the second row, 2 into x1 is 2x1. Minus 2 into x2 is minus 2x2. 1 into x3 is x3. This is equation number 10. Okay. Now coming to the third equation, take the third row. Okay. Multiply this element minus 7 into x1. You will get the third equation, minus 7x1. 2 into x2 is plus 2x2. Minus 6 into x3 is minus 6x3 equal to 0, equation number 11. Okay. So multiplying the two matrices, I have got 3 equations. Using these 3 equations, I can easily find what is the value of x1, x2 and x3. So here all the 3 equations are different. Thus we can solve this using any 2 equations. Thereby I will be just taking 2 equations, equations number 9 and equation number 10. Okay. Again, to solve this, I will go for the cross multiplication rule. Again, I will write here x1, x2 and x3, and below that I must write some elements here. How do I write that? Let me show it here. So here x1 is the first variable, right? So here x1 is the first variable. Leave the coefficients of the first variable here. Jump to the right. You can see here 2 and minus 2. Okay. Write those elements here below x1. Then again go to the right. You have 0 and 1. Right? 0 and 1. Okay. Now go back to the start position. Now you can see here, once I come back to the start position, the coefficients are minus 1 and 2. So you can see here it is minus 1 and 2. Go to the right here, it is 2 and minus 2, 2 and minus 2. So here I have written all the elements below x1, x2 and x3. If you simply cross multiply, you will get the answer. 2 into 1 minus 2 into 0 is value of x1. 0 into 2 minus 1 into minus 1 is value of x2. Minus 1 into minus 2 in minus 2 into 2 is x3. This is called as the cross multiplication rule, but we will solve it in the general method. Okay. Now here write the ratios of x1, then x2, then x3. Okay. Now write the determinant here. Below x1, simply draw 2 lines. You have the 4 elements. Just fill it here. It is 2, minus 2, 0 and 1. Okay. Now below x2 again, draw the 2 lines here, determinant here, and here draw 2 lines. Fill the elements here. It is 0 and 1, minus 1 and 2. The last one is x3 by determinant of. Now here again below x3, draw 2 lines. So these are the 4 elements, that is minus 1 and 2, 2 and minus 2. Okay. So easily I have got the ratios here, x1 by determinant, x2 by determinant, x3 by determinant. Okay. Now let us solve these determinants. Okay. So you know that I have to find the solution for this determinant. Okay. x1 by, x2 by, x3 by. Okay. So for determinant of second order, the solution is the cross multiplication. You have to go for AD minus BC. So here you can see x1 by 2 minus 0. That is 2 into 1 is 2 minus 2 into 0 is 0. Okay. Coming to the second one, again here it is 0 plus 1. 0 into 2 is 0 minus of 1 into negative 1 is plus 1. So it is 0 plus 1 equal to 2 minus 4, that is minus 1 into minus 2 is 2 minus 2 into 2 is minus 4. So let me simplify this. It is equal to x1 by 2 minus 0 is 2, x2 by 0 plus 1 is 1, x3 by 2 minus 4 is minus 2. I got the solution. Therefore, x2 is equal to 2, 1 and minus 2. Okay. Therefore, the eigenvector for lambda 2 equal to 3 is x2 is equal to 2, 1 and minus 2. Here I have found the eigenvector for the corresponding eigenvalue equal to 3. The last one is to find the eigenvector for the lambda 3. Right. Let us go to the next step. Case 3. Putting lambda 3 is equal to minus 4. Again, I will take the equation number 5. Substitute the value of lambda is equal to minus 4 here. You will get 2 plus 4. Let me again show it here. This is 2 minus lambda, the first element of the first row. Here you can see 2 minus of minus 4 is plus 4. Okay. The second row, second element, it is 1 minus lambda. It is 1 minus of negative 4 is plus 4. Last one is minus 3 minus lambda. The third row, third element, it is minus 3 minus of minus 4 is plus 4. So I have substituted the value of lambda 3 is equal to minus 4 in equation number 5. Let me simplify it. Now this is equal to 2 plus 4 is 6, 1 plus 4 is 5, minus 3 plus 4 is 1. I have to multiply these two matrices to get the three equations as usual, right? Okay. Now take the first row and the column. Okay. The first element is 6 into x1 is 6x1. 2 into x2 is 2x2. 0 into x3 is x3. 0x3 equal to 0, equation number 12. Okay. Now next equation, I'll go for the second row. Okay. 2 into x1 is 2x1. 5 into x2 is 5x2. 1 into x3 is x3 equal to 0 is equation number 13. I'll go for the last one here. The last row is minus 7, 2 and 1. So it is minus 7 into x1 is minus 7x1. 2 into x2 is 2x2 and 1 into x3 is 1x3 equal to 0 is equation number 14. So multiplying the two matrices, I have got again three equations. Using these three equations, I can easily find what is the value of x1, x2 and x3. Okay. So I have taken the three equations. All the three equations are again different here. Thus, we can solve it using any two equations. I will be taking equation number 12 and equation number 13. So again, I will go for the cross multiplication rule. Write x1, x2, x3. Below that, we must write some values here. How do I write is, let me show it here again. Leave x1 because I am starting from x1. Start from x2. Write 2 and 5 here. 2 and 5. Okay. Then go to the right. You can write 0 and 1. The coefficients of x3. 0 and 1. After finishing this, go back again to the start point. Okay. Start from x1. Now here you have 6 and 2, the coefficients of x1 here. Write 6 and 2 here. Then you have, go to the right side. You have 2 and 5 coefficients of x2. Write 2 and 5. So I have filled all the points there. Okay, all the values there. Now let me go for the solution. It is equal to, write the ratios x1 by, x2 by, x3 by. Okay, determinant of. Below x1 write determinant of. Now simply here draw the two lines. The values are, the elements are 2, 5 and 0, 1. Okay. Now go for the second one, x2, determinant of below x2, draw two lines. So the elements are 0, 1 and 6, 2, right. Now go to the third one, x3, the determinant of below x3, draw two lines here. The elements are 6, 2 and 2, 5. So I have found all the three determinants below x1, x2 and x3. Okay. Now using this, I will try to find the third eigenvector. Now it is equal to ratio x1 by x2 by x3 by, we know that the solution for the 2 by 2 determinant is cross multiplication is a into d minus b into c. So therefore solve this first one, okay, this determinant. It is equal to 2 minus 0. It is 2 into 1 is 2, minus 5 into 0 is 0, 2 minus 0. Now coming to the second one, you have 0 into 2 is 0, minus 1 into 6 is minus 6. The third one, 6 into 5 is 30, minus 2 into 4 is 2 into 2 is 4. Okay. So I got 2 minus 0, 0 minus 6 and 30 minus 4. Let us simplify this. It is equal to 2 minus 0 is 2, 0 minus 6 is minus 6, 30 minus 4 is 26. Okay. So here we can again simplify this because we have a common factor here, 2 is there. So we can go for divide by 2, it is equal to 1, divide by 2 it is equal to minus 3, divide by 2 is equal to 13. So solution is 1, minus 3 and 13. Okay. So here the eigenvector x3 is equal to 1, minus 3 and 13. Okay. Therefore the eigenvector for lambda 3 equal to minus 4 is x3 equal to 1, minus 3, 13. So this is the eigenvector for the corresponding eigenvalue minus 4. So the solution, the eigenvalues of matrix A are lambda 1 equal to 1, lambda 2 equal to 3, lambda 3 is equal to minus 4, and eigenvectors corresponding to lambda are x1 equal to 2 minus 1 minus 4, x2 equal to 2 1 minus 2, and x3 is equal to 1 minus 3 and 13. So this is the solution. I hope all of you have understood the problem. Thank you.